Hello everyone, welcome to this video. In this video, let's have a look at this question which suggests that we need to prove that every group table is a Latin square. That is, each element of the group appears exactly once in each row and in each column. Right? So first of all, let's suppose that the G is the given group, and we also suppose that two entries in one row of the group are equal to each other. Why we are doing this? Because we wanted to prove that they cannot be, right? So we'll be proving this by the method of contradiction, that each element of the group that appears exactly once in each row and each column. So we assume that two entries are equal, right? And how are the entries formed? So let me tell you in this way. Let's construct a group table, right? And let's write three elements within it, say A, B and C. Here also we are writing A, B, C, such that this A, B, C, they are distinct elements. So how would be this entry appearing? It would be the multiplication of this and this element, correct? So it would be A square. Next would be A into B, right? So it would be A, B, and next would be A into C. So it would be A, C. Next one B into A. So it would be B, A. Next B into B, that is B square, right? And then B into C, that is BC. Next element would be C. Similarly, we would have CA, CB and C square. These would be the elements. Now here we wanted to see, we are assuming that this element and this element are equal. So suppose that AB is equals to AC, right? And here we are assuming that, suppose in a row headed by A and columns headed by distinct elements A and B, we have the same entries, right? So which same entries are we talking about? We are talking about AB, that is equals to AC, right? So once you have this thing, so that is, we are talking about AB is equals to AC. Here you can here AB is equals to AC. So you can apply the left cancellation law, or you can pre-multiply with what? A inverse. So that here you would have B is equals to C, right? So this gives us a contradiction because we have assumed the elements to be distinct, right? They are not the same. So we would say this is a contradiction because we have assumed the columns, they were headed by distinct elements B and C, right? So so whatever we have assumed was incorrect. So our assumption was incorrect. Therefore, we would say no two entries in either row or column will be equal, right? So here you can see this result is very powerful, that if you move row wise you would have no same element, and if you have move column wise also you would have all the distinct elements. So these entries, they would not repeat when you are traveling column wise or you are traveling row wise, right? So we will be making use of this result in order to fill up our Calais table, as we'll be looking at in the upcoming question. So I hope you understood this question well. That is it for this video. Thank you for watching.